production.
So excited today for a demo with Mark Fussell, and Mark is with Diagrid. He's the CEO of Diagrid. You may be familiar with Diagrid. They are the distributed systems API company, as I like to call them. But I'm going to really let Mark do the details here about what the company provides and tell us a little bit about what we're going to do today. Hey, Mark.
Good to meet you, Alex. Fantastic to be here. Yeah, let me dive in a little bit and talk to you about what we do at Diagrid and who we are, and a little bit about the projects we work on. Who are Diagrid? Well, Jeroen and myself, co-founders, we set up Diagrid about 1.5 years ago, and we're very much a developer-focused company. We like to say that our mission is about to boost developer productivity, help you build applications, particularly distributed applications running on platforms like Kubernetes, which is all of the focus mostly of the industry today when we talk about cloud native applications. And so that's who we are. We're here about developers. We're here to take open source technologies, and particularly one that Jeroen and I both created. We created this project called Dapr. And I'd like to talk to you a little bit about Dapr, if that's okay.
I would love to get the details on Dapr. I've been really interested in what you all are doing. And you came from a long background at Microsoft. I think you say in your LinkedIn profile that you spent 21 years there.
I did, yes. I spent a lot of time there. I actually was very early in Azure and built a distributed systems platform that runs most of the major Azure services there. And then about 4 years ago, Jeroen and I started this project called Dapr. And we did it whilst at Microsoft, but we saw this need for developers to build distributed applications on platforms like Kubernetes, but also other platforms that run things as well. So, yeah, I spent a long time at Microsoft and spent many hours and days and weeks and years building distributed apps, for Microsoft itself and also for developers using it all. And let me talk about a few of the things that we encountered there as well. What we encountered was that developers not only building like services at Microsoft, but in today having to build like this fictitious e-commerce application. And developers are building these for all the right reasons. They're often called cloud native distributed apps. They consist of many different processes that are run. They do it because they want to scale independently, ship independently, be agile. But the challenges is that when you actually get down to it all, there are many things that developers to deal with. How do you discover other services? How do you do security between them? How do you do resiliency? How do you do telemetry? And so all these things, before you know it, developers are building a platform and not their application themselves. And so we looked at this and said, hey, how can we make this better for developers? What do we do? And so we started this project called Dapr, or Distributed Application Runtime. And it's all about building applications on different platforms and making developers productive. And it does that through a set of APIs.
So I've heard about this a lot, where developers spend a lot of time setting things up, correct?
Yes. Well, developers spend a lot of the time figuring about, how is it that, for example, when they build an application, here's the set of APIs. How do I create a long-running stateful application? So say I have an application that is durable, it fails over, recovers its state, maybe like a shopping cart that I want to do. How do I make that durable? Or how is it that I send a message between application A and application B, because you have an event-driven architecture, and I'm using a message broker to say all those ones listening on these messages go off and do some more business workflow. So developers, instead of having to get focused on the business themselves, are building these platforms for communication, for state management, for security, managing secrets, even things like workflow. Workflow is probably the most common thing that you find in line of business applications. Do A, do B, do C, send a message off to a customer, wait for it to come back. And so Dapr codifies all of these best practices into a set of APIs, which you can access over HTTP or gRPC. And now they can come at it from any language of their choice, .NET, Python, Java, PHP, and now build and be productive building these things, particularly if they're running on top of Kubernetes. Kubernetes has got nothing to do with developers, and yet they're told to build on top of it all. So we've seen, by using these APIs, developers are anywhere between 20 and 40% more productive in building their applications. Does that make sense?
Yeah, it does.
Yeah, so that's what it's all about. And that's exactly what we've experienced, really. Developers taking these APIs, and it's really about the best practice. Why write the code yourself when you can take advantage of these things? So that's what Dapr is. And it'll run on any platform, but Kubernetes is the dominant platform. The way it runs, by the way, is that you basically have this sidecar model. So you write your code, and when you run an instance of your application, Dapr pops up as this little sidecar, and it does all the heavy lifting to help your application achieve its goals. So you'll see here, these are some examples of the API calls. And if I want to call the order method on the cart application, wherever it's running, say in my Kubernetes cluster, all I do as a developer is do this local host call to my Dapr sidecar running on port 3500 in this example, call the invoke method and say, hey, invoke this order method. And Dapr does discovery, security, retries, and all that sort of side of things. And you just do an API call from a developer perspective. Does that make sense?
Yeah, it does. I'm curious why you chose the sidecar model.
Well, that's kind of like a separation of concerns. And it's pretty important because, you can include, typically libraries as all bundled apart, but by the separation of concerns, you can update Dapr independently to your actual application itself. So there are actually two major benefits. One is you can roll out new versions of Dapr and you don't have to rebuild all your application code. And also, it's where you actually discover issues. Often when you pull all these runtimes together into one application, you don't know whether it's the runtime or your application that's being, having issues with inside it all. So the separation of concerns, particularly in a distributed application environment, mean that you can update things independently, resolve issues independently, and effectively, and the latency is almost minuscule. In fact, the end-to-end latency of adding a call for service invocation end-to-end and back again through Dapr, through one application to a Dapr sidecar, across the network to another sidecar, to that application, and all the way back again, is less than a millisecond. So, you get great performance as well as separation of concerns. There's a little bit more to this as well, because what it also does that's key is that behind those APIs is this concept of components. And this is how you tie some infrastructure through to your application itself. So you can say, hey, on that state management API, I can put the state in any one of these number of state stores. So my code remains the same, but I can store my state for my application, like my shopping cart or my gaming session state or something, into one of 30 different state stores. And so I can swap these infrastructure kind of components out and move from, say, one cloud to another, or my local development machine to the cloud, and thereby provide portability of code, consistency of code, and that's a very key aspect to all of this that developers love, because it gives this dynamic behavior about how you tie infrastructure to your application without you having to pull in a specific SDK or throw away your code and learn these things. So effectively, it's a codification about how best to use that SDK for that particular technology. For example, the state store and saving state. So this is another key aspect to this. And this is shown as an example here, where I built an application, consists of 3 services, 1, 2, 3, and I might host it on Azure with an Azure Service Bus for messaging and a secrets key vault to pull out secrets and a Cosmos DB database. But I might switch that application without changing my code, but changing the components, so that I'm using AWS simple notification service, with the key management service of AWS and DynamoDB, or switch out for Google ones as well, or taking advantage of HashiCorp Vault, actually, in this case. So, this pluggability makes multi-cloud story, which we see emerging today, is very important. A real truth behind the reality of making code run in multi-cloud ways.
It almost seems like the ability to run these component models in different cloud services, but they're almost formatted in a manner that it's almost like copy and paste a little bit.
Yeah, you just change the metadata settings of it. So that, going back to those APIs that you called it, that doesn't change, but I can just switch out the metadata API of how I talk to that particular component. So then Azure Key Vault has some particular ways to communicate with it all. And it's just a declarative file. I haven't shown it here, but a declarative file just allows you to swap that one out. But how I send the message, it doesn't change. So that's the key behind it all. The Dapr project is pretty awesome in terms of the community. It's got a massively vibrant community. It's the 10th largest project inside CNCF. So Dapr was donated into the Cloud Native Computing Foundation in 2021. And in terms of the project size, in terms of the contributors, the authors, we see there, of the 160 plus projects that are inside CNCF, or 157, there's it's the 10th largest. But I think the biggest interesting measure is that you have a big Discord community of 6,000 members. You got these nearly 3,000 contributors, and the contributors are the people who spend their time and their energy and their passion to make Dapr a better place. And you can see that Dapr effectively is built by many different organizations, from large clouds to many other sort of organizations, including end users. So I think that is kind of a wonderful thing about Dapr's projects in terms of its growing community. So that's a little bit about Dapr. What we tend to see is that Dapr runs on top of Kubernetes best, and we see many people deploy Kubernetes. It's you probably see this as well. Do you see a lot of Kubernetes usage now in terms of organizations?
Oh my gosh, yes.
Yeah.
It's and it's popular. It's more popular than ever on the news stack.
Yeah.
As a topic.
Yes.
And I think that is also a testament not just to Kubernetes but to Docker and containers too, and the ease of use of distributed systems.
Exactly. But most of that today is focused around operations.
Yes.
How do I do operations? How do I deploy and roll out and, set up networking and blah, 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 and all this sort of stuff, and then, building applications is kind of less of an exercise to the reader. And so, going back to what Dapr is all about, we see that, this synergy between Dapr is the best way to build your application on Kubernetes and accelerate that. Kubernetes is a great place to run them, because it manages to compute and does the failover and that sort of thing. Dapr is the best way to build the application that can take advantage of that, because you've got to look at things, for example, like security in the application itself. How is it I set up security between applications? And Dapr provides this concept of like identity and security that Kubernetes doesn't, because it's infrastructure and Dapr's application. So you end up Dapr providing a great zero trust security model, for example, in the application, because you start with that as just one of its many things.
I see. So, in thinking about what you were showing before, those companies that are using Dapr, what are some of the more popular use cases that you see?
That's a great question. Yeah, we see it. All sorts of companies do this. So, for example, IoT companies who are gathering data from external systems, like we've dealing with a great company that brings in lots of IoT data from external manufacturing or from lighting systems, and then they push it in and they build their application that tracks manufacturing equipment or lighting systems, things like that. We see a lot of financial people use Dapr. Particularly, actually, what also is happening with Dapr is that it's emerging inside of platform engineering, as platform engineering has evolved and moved from the highly funded large financial companies to like everyone else, because they have multiple applications. Dapr is sort of an API on top of that. So we see a lot of use in platform engineering, whether that's financial applications like trading applications or healthcare applications. It's really very, very diverse. But in the end, event-driven architectures, messaging, direct communication, stateful, long-running line of business. Like Dapr workflow is incredible. It allows you to build, for example, we've got a great case study that's published from Zeiss, who does lens manufacturing, and they generate lenses all around the world. They build them for particular customers. Classic line of business application. It runs workflow. And sends messages, updates to customer. So workflow applications built around Dapr are very, very common, and they constitute many types of things that we see today. The thing is, though, of course, that running on Kubernetes has its own challenges, and what we see is effectively there are many challenges with what you have to do because of Kubernetes and because of Dapr itself, how do you stay up to date with the latest versions of Dapr? How do you roll out new versions of your applications? Dapr has a huge amount of amazing metrics. How do you actually take advantage of looking at those metrics and understanding what you can do? For example, often there's latency inside your application, and Dapr will send out a metric of like, this particular application is slow. How do you see all of those things? So you've got all these challenges that are still there because of operating things, particularly on Kubernetes. And so that's where we, Diagrid, came in, and we said, well, if Dapr is a great way to build it and Kubernetes is a place to run it, what is it that we can do to help developers and operators manage Dapr on top of Kubernetes? And so that's where we built our first service. It's called Diagrid Conductor. And what it does is it helps you operate and manage Dapr on top of Kubernetes. So think of it as a managed version of Dapr on Kubernetes in terms of how you can do those things.
I'd be curious why you decided to build it, though, and what was lacking before you did.
Yeah, I mean, going back to this slide, it was a little bit of this. So, for example, we saw, what Dapr does is it provides, for example, certificates for each one of the applications that are running, so they can communicate securely. So if you can imagine you want security between your applications, Dapr does this great job of issuing certificates. But what was lacking is that those certificates expired, they ran out, and then before you knew it, there was downtime of your application. So the operational aspect of this was, how do I make sure I do certificate renewals? And you'll see, for example, as well, that often people over-provision too many resources for their application. So how is it I optimize my resources? So that's really where we came in, and sort of the missing piece here was operationalizing Dapr on Kubernetes in a more productive way, so that enterprises can, again, focus on building their application and not focus on operating Kubernetes.
Okay.
So, for example, we improved, what Conductor does across these three pillars of operational excellence, security, and reliability. We can improve your downtime, prevent your downtime every year. We can improve your best practices in terms of stopping you reading hours and hours of documentation. We can improve your overall cost expenditure around these things. But I think a great thing for me to do is show you a little demo. And because I think Conductor is a magical service that helps you kind of visualize what's happening inside your environment. And the way it works is you take this Kubernetes cluster and you drop our little Conductor agent into your cluster, and then you hook it up to our SaaS service running in the cloud, and then you can see all your clusters and you can manage them and see all of the interesting things that are happening inside there. So I can give you a little demo, and then we can switch back to that. Does that sound good?
That's great.
All right. Let me just switch over here a moment and show you this view. Can you see that?
Mm-hmm.
So this is Conductor, and what you get when you first dive in here is you get a little view of all your different clusters that you've hooked up the Conductor service to. So you see that I got 3 clusters here. This one's actually a local dev cluster running on a local machine. So it's not just kind of running things in the cloud. And you can see that, I can see the status of the Dapr running on those clusters. I can see the status of, is it healthy, the control plane. I can see the number of applications. So I get this overall view, and I can, we work with customers who have, many of these clusters, tens, hundreds of these clusters that they can look across and see Dapr. And then you can dive in. I can have this sort of more detailed view of that cluster from a Dapr viewpoint. You can see here that this is the version of Dapr deployed to that cluster. You can see that it's got the high availability set up for the control plane, which is crucial for production. You can see that actually I've got certificate management on this. So my certificate for my applications, issuing them, is going to run out in 21 days. I better do something about this. And lots of interesting information around the control plane. Everything that gets deployed on Kubernetes has a sort of control plane, and Dapr is the same thing about this. So you see like the CPU usage here, and you see the memory usage of the Dapr control plane. But this is kind of just an overview. I think the great thing that Conductor provides is it gives you this insights into things that can help you. So you see here, there's this advisor that we built. So imagine, you have to read tons and tons of documentation, all the best ways, like everything, to run something well on top of Kubernetes, because Kubernetes requires you to think about it all, and so this is what the Dapr advisor does. is it looks at your environment and tells you things that you should be doing that are best practices for running Dapr on Kubernetes. So, and we divide these into security, reliability, performance, observability. So, for example, here I'm diving into the security advisors. You'll see that one of those components that we were looking at, describing earlier, in this particular case, someone's checked one in that contains some sensitive information, and we flagged that. We've said, oh, someone's connecting to this component. Instead of using a secret that's stored inside a secret store, they put the password information inside this. So this particular component here, called the OMS PubSub component, it actually wrongly has some security requirements. I can actually go and look at that and see, oh, look, this is the password and value. We obfuscate the values. You don't actually see them. But this isn't a good practice. You shouldn't check passwords in with your component manifest. This is one of those components I talked about earlier, talking to a Kafka message broker. And you really should take this out of here. So those are sort of things it detects.
So it detects those anomalies.
Exactly, yeah. In this case, a security thing, saying that,
right.
Don't check passwords into code. Not a good idea. In this case, a component.
But it happens, right?
Yeah, exactly. So that's that. And then, of course, going back to the advisor, you can also do things like performance. In this particular case, we actually look at all your applications that are running. And we can actually look at recommendations for setting the resource settings for your application itself. So this is a common thing that happens. Someone provisions an application. They don't know whether to give it one core or this amount of memory. They usually over provision it because they're a little bit nervous about the thing not having enough of the resources. So what Conductor does, it monitors those over a 15-day period. And for both sidecar of Dapr itself and your application, it suggests CPU and memory usages that we've seen typically save people 50 to 80% of their costs because they've over-provisioned. So the sort of cost analysis of your application environment and how you should optimize it is pretty crucial.
So it seems like what you basically have been doing is you've sought out the most complex matters that developers face. And then you have looked at those challenges such as PubSub issues or state management or observability or secrets management, as you just discussed. And you've abstracted them into the service that you provide. So that provides the developers with that ability to focus on that business value, really.
Yeah, exactly. I mean, Dapr, just as you described, does that. It gives that abstraction, and then, of course, this Conductor service helps you operate Dapr in the Kubernetes environment. And so, for example, let me show you this. This is an application I've got running here. So these are the list of my applications that are running. But the beauty about it all is actually I can go in and build this application graph, and it live dynamically pulls out all of the messages between my application. You see that these dotted lines represent PubSub messages, and you'll see that these solid lines here represent service invocation messages. So it's a live view of my application. But I can drill down into this, and I can isolate these, so I can see more detail about what's happening with any one of the particular applications. And you'll see here that this order service here is sending messages through to a PubSub messaging service here, and you can see that I can do latency inside it all. In fact, what I'm just going to do is I'm just going to kick this off a little bit here a moment and just simulate some errors inside here. So I'm just going to roll out this particular application, and actually this application will cause a few errors, and we'll see some things happening inside it all. But if I go back into this applications view here and look at that again, I have this detailed view of my application that actually bridges between the developers and the operators, that I can actually see metrics that are happening through my infrastructure, like this particular component here. I can see error rates, I can see latency rates, and I can see connectivity between these things. And I can then dive into particular ones of these services inside here and see latency for that as well. So this is very interesting way for a developer and operators to kind of collaborate, find things that are happening in production in terms of latency issues, see those Dapr metrics, and discover things that are happening. And you can actually sort of dive in here to the actual application itself, see its memory usage, see its CPU usage, and look at a list of notifications inside here. So you see that, I can see that this notification of a metric showing that this component was failing to do a call in a particular time. I can sort of dive down and see these sort of latency issues that are happening. You see that there was a latency issue for this application that was taking 10 seconds. It eventually got resolved. But if I look back over time, you see that this application has been having latency issues by spikes of latency that have been happening. And I really should be looking at why is this application having these big spikes of latency, and what I can do. Because what we've been able to do in Conductor is set up these notifications of latency happening and signal those to the operator so they can investigate them and bring in a developer team. Does that make sense?
Yeah. Well, Mark, we have about a minute or two left. And then so maybe what you could just sum up here is like, what's next for Diagrid? What's next for Dapr and Conductor?
Yeah, well, I mean, Diagrid, as I say, we're all focused about developers, and we're excited that, getting Conductor out there to more and more users. We've seen a huge response to this in terms of having, teams come to us who've currently built Dapr today into their systems. And so we're here to help you not only adopt Dapr and be technical advisors, architects, and give you advice around that. But if you're adopting Dapr and you're thinking to yourself, how is it that I can operationalize this and make it smooth within inside my company? We're here, Diagrid, to help you operationalize your Dapr instances inside your application to not only provide you advice about how to do it all, but with Conductor service, be able to really take advantage of you understanding what's happening inside production systems and make sure they're more reliable and more secure. So, we're thrilled to be here for developers, and you'll see many more services come out from us later this year. Hopefully, you'll have us back when we'll talk about a service we're shipping later this year that actually hosts managed Dapr in the cloud, so it goes serverless. And you don't have to do anything to do with Kubernetes, which I think is fabulous when we go down that path.
Well, that sounds like more magic to me. Mark, thank you so much for taking the time to talk. Mark Fussell, who is the CEO and founder at Diagrid, and thank you so much for your time.
Well, it's fantastic having me, Alex, and we'll catch up again soon.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.